Okay, we are going to talk about calculus, and calculus is all about. It's got so many definitions, a systematic arrangement of stones. It means a lot, but initially we are just going to talk about the differentiation or finding the derivative. Okay. On the other hand, we are going to talk about the integration, okay, or the integral. When you talk about the integration, here we'll be talking about increase in the values of x. Here, it will be the opposite. We'll be talking about decrease. And so, first of all, you have to learn these two. The integral, the increase in the values of x. You must learn the decrease in the value of x with respect to a particular equation or function before knowing the application. Otherwise, differentiation, we'll be using it to calculate the gradient, the dy dx. Okay. When we go to the application, we'll be using it also to find the maximum and the minimum values and minimum values. Okay? We'll be using this in equations of motion in physics to calculate the equations of motion. We'll be using this, okay, to calculate we can say, okay, what else? The maxima and the minimum values, or the rates of change. We can say the rates of change, where we say the small increment. The small increment. Again, we can say, on calculus, when we say the integral here, we'll say we'll be calculating the volume of a given figure expressed in an equation form, the area, and so many more. Equations of motion will connect to these things. And so let me show you the simplest ways in which we can reduce, the simplest ways in which we can integrate and differentiate. So there are shortcuts. There are short ways in which we write this. We can say the differentiation of y with respect to x. They can say find the dy dx of this equation. Okay, maybe this is question 1. Question 2, they can say y equal to x plus 1. 3, they can say y being equal to x to the power of 4. Question 4, they can say differentiate x plus x to the power 2 when the whole equation is equal to y. Let me show you the simplest. Differentiation, its abbreviation is dy dx. You are differentiating the equation y with respect to x. We are only giving respect to where there is x. And so this will equal to, you drop the power that is there, we've dropped it, and then reduce the same power by 1, which will mean 2 to the power of x. That becomes the solution. We are only giving respect to x, so we will not even consider this. Okay, we're only giving respect to where there is x. We're differentiating y with respect to where there is x. And so the differentiation will mean drop the power and reduce the same expression by 1. And then this is the same as saying 1x to the power 0. Any number or letter raised to the power 0, it's 1. Okay, and then here we have y equal to x to the power of 4. We are going to drop the power and then reduce the whole expression by 1. We are reducing. This will mean 4x to the power of 3. Okay. For this one, we're only going to give respect to values or letters that have an x. And so we'll say here there is power of 1, here there is power of 2. So we'll drop the 1, and then reduce the power by 1. We are adding. Drop the power, reduce the whole power by 1. This will mean 1x to the power of 0 plus. This will be 2x to the power of 1, of which in mathematical terms this is same as saying 1 times 1, it's 1, plus 2x. So these are the answers. Okay? So calculus is all about integration and differentiation. You only be working with reducing the powers and increasing the powers. So let's do some more. Let's do some more of differentiation. So I'm saying derivative of y. We are talking of expressions, equations that have a y. So these can change, but you're giving respect to x. You can have an equation like that being equal to x plus 2 to the power of 3. Okay? And then we say find the dy dx of this. We're simply saying here we have this. We're only giving respect to x, so we'll say I have this x. I should first of all know what the derivative of this. That's when I can multiply. Okay, let's take this as x, this one, and then that's when you can multiply by the whole lot of this function when you reduce the power. Okay, so I'll say let me bring down the x. 1 times, bring down x, reduce it by 1. Multiply by the whole expression when the power is reduced. That is all. Meaning your dy dx will now mean 1 times x to the power of 0 multiplying x plus 2 to the power of 2. 1 times 1 times the whole lot of this. It means you still remain with your x plus 2 raised to the power of 2. Okay? So it's more like we are just reducing the powers. When you reduce the power, then you are differentiating. So dy dx, the other name is the differentiation. Okay, the other name is the derivative. Okay, so we'll say any equation involving y equal to, they can give us a lot of expressions. X to the power of 3, x to the power of 2, plus x plus 10. So you say, I'm differentiating y. Y means all of this, giving respect to only where there is x. So we'll not consider this. It doesn't have an x. So we'll just differentiate up to this point. And then we'll say the derivative of y with respect to x is such that you drop the power and then reduce the power by 1. Drop the power, reduce the power by 1. You drop the power, reduce the power by 1. And then this is the same as saying 4x to the power 3 plus 3x to the power 2 plus 2x. That is the derivative. Okay. Let's come now to the opposite of differentiation. It is integration. The opposite of this, so differentiation, derivative, dy dx, actually it's reducing of powers. Now when we say the integration, we are simply saying you are increasing the power. The other symbol, more like an S, like that. Okay. So the other name, they can say, find the integral of the following equation. These are the same. Integrate or find the integrals of that symbol. So they can say, integrate the following x to the power of 2. So we say the integral of y with respect to x will be such that we only focus on x. There we were dropping the power, but this time we are adding. Add 1 and then drop the result plus a constant.